Hello friend, how are you? I hope you are all will be fine. I'm also fine, thank you. Welcome to your channel. Let's start today new course of Boron family. Today we will be study about we will start Boron family. Today we will be start Boron family. Boron family is also called it is also called group third elements. Group third of A elements are also called in general it is 13th groups and periodic table in sequence. It is also denoted by that is in this groups in this family boron, aluminium, gallium, indium, indium and thallium. These five elements, these six elements are placed in the 13th group or group third of A, also called that is boron family. Today we will be explain in today lecture we will be explain boron family with very details. Let's start the topic. In this course we will be discuss these five things, this general thing. First of all, we will be discuss general characteristic of group third elements. General characteristics of boron family. Number two, we will be discuss abnormal behavior of boron, also called anomalous behavior. Abnormal behavior of boron. Behavior of boron, also called anomalous behavior of boron. Anomalous behavior of boron. And third, we will be discuss in this lecture comparison of boron and aluminium. Comparison of boron and aluminium. And we will also discuss the diagonal relationship between silicon and boron. Diagonal relationship between boron and silicon. Also, we will be discuss with very detail the boron and the compounds of boron and the compounds of boron. After that we will discuss aluminium and the then a compound of aluminium and then compound of aluminium compound of aluminium. So in this family, in this group, in this lecture, in this class, we will be discuss general characteristic of boron family. There are many up to 10 or 12 different general characteristic of boron family. Today we will be discuss few of them, and after that, a few of them we will be discuss in next lecture. Okay, let's start topic. General characteristic of boron family. Let's start general characteristics of boron family of boron. In general characteristic of boron, first of all, what is the atomic number? Atomic number of boron family is, I am showing here. This is boron has the atomic number 5, while aluminium has the atomic number 13 and gallium has the atomic number 31. First of all, after the 5 you would add 8 plus 8 to 5, you will get 13. After that, plus 18, addition of plus 18, you will get 31. After again you will add plus 18. You after the adding of plus 18, summation of plus 18, you will get 49. After that, you will add 32, you will get 81. It is the atomic number of these groups, boron family. Boron has 5 atomic number 5, aluminum has 13, gallium has 31, indium has 49, thallium has 81. After that, the element that comes, that is also called UUT. It has the 13 atomic number. It has 13 atomic number, 113 atomic number. Means after the addition of plus 32 to 81, you will get 113. These are the atomic numbers of boron family. So after that, come to the next point, that is electronic configuration. Electronic configuration, next characteristic of configuration, boron family. That has boron that is 5, atomic number. It have 2s2, 2p, 1s2, 2s2, 2p1. That is the atomic configuration of electronic configuration of boron. After that, aluminum, which has 13 atomic number, so it have 1s2, 2s2, 2p6, 3s2, 3p1. The electronic configuration of boron. The electronic configuration of aluminum, the electronic configuration of gallium is which has atomic number 31, so it become 1s2, 2s2, 2p6, 3s2, 3p6 according to Horn rule, 3d, 4s2, 3d10, 3d10, 4p1, 4p1, 4p1. These are the electronic configuration of gallium. After that come indium in the next elements of this group. Indium, which has 49 atomic number, so it will become, it means that here in this case in gallium, 3d orbital, 1d orbital will enter into the electronic configuration, will enter into the inner shell. So in indium, 49 atomic number, so their electronic configuration become 1s2, 2s2, 2p6, 3d10, 3d10, 4s2, 4p6, 4d10, 5s2, 5p1. These are the electronic configuration of the indium. And after that, thallium, which has the atomic number of 81, so their electronic configuration become 1s2, 2s2, 2p6, 3s2, 3p6, 4d10, 3d10, 4s2, 4p6, 4d10, 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 and 4f14, 5s2, 5p6, 5d10, 6s2, and 6p1. These are the electronic configuration of the boron family. So here in this case, in boron, here is the second case, the outermost shell, the valence shell is second shell, which have 2s and 2p, means the inner shell are also called penultimate shell. What is penultimate shell? Penultimate shell means the shell that is one inside the outer, means that will be n-1, the outermost shell which is n-1, means one is the subtraction of one from the outside. So this is here is the two outermost shell, the valence shell is two shell, so n minus 1 mean 2 minus 1, 1 will be the valence shell, 1 will be the penultimate shell. So here in this case in aluminum, here is the penultimate shell, here is the outermost shell, the valence shell is 3 while the penultimate shell is 2 second. Similarly in gallium, the outermost shell are that according to sequence, it will become 3d10 4s2 4p1. Yeah, here in this case the valence shell is the outermost shell is 4 while the penultimate shell is which is n minus 1 which will become 3, the third is penultimate shell. So here in this case in gallium also 3d enter of 3d orbital enter of d10 electron occur in the gallium which is in penultimate shell. But here in indium the valence shell is 5 shell, 5s2 5d 5p1. In general the electronic configuration of the boron family will become ns2 np1. This is the electronic configuration in general, this is the electronic configuration of the boron family. So here in each element at last it will become, that will be either 6s2 6p1, either it will become 5s2 5p1, like in case of thallium which has become it in last of 6s2 6p1, while in indium it became 5s2 5p1, while in gallium it became 4s2 4p1 at last, the valence shell. So in general n is 2 np1 where n is the valence shell of the electron of the atom. So here in indium the penultimate shell will be 4 shell, the fourth one shell will be 4 shell will be also called klmn. The first shell is called k shell, the second shell is called l shell, the third shell is called m shell, the fourth shell is called n shell, the fifth shell is called o shell, the sixth shell is called klmnop, the sixth shell is called p shell. So here in this case in the fifth shell this will be o shell will be called that will be called valence shell, while the in case of indium, while the fourth shell the n shell will be called penultimate shell, because it is inside, the valence shell. While in case of thallium, coming to thallium which has 81 electronic configuration, so their electronic configuration become 1s2 2p6. Here in this case in thallium 4p1, in thallium's the valence shell will be 6s2 6p1, that is valence shell also 6 shell is also called p shell. So the p shell will be called 6 shell, while the o shell will be called penultimate shell. In case of indium o shell are valence shell, while in case of thallium o shell is the penultimate shell, means in each case one orbital one shell are added to their electronic configuration. I hope the electronic configuration will be clear. If you have any confusion, if you have any question, you can rewind the video. After that, you will be get cleared. So let's proceed the topic to the next point. Now I am cleaning the board. You can take screenshot or you can rewind the video because to proceed the topic. The third property of boron family is the third characteristic of boron family is, let's explain, tell you something about abundance and occurrence of boron family. Occurrence of boron family, abundance and occurrence means the where the boron family, where these elements means that is gallium, aluminum, boron or indium or thallium, where they are located in most major quantity and where in less quantity. So aluminum is the most abundant, aluminum, that is aluminum Al, aluminum which have the atomic number of 13, it is the most abundant metal in this group. It is the most abundant metal in this group. Why these are most abundant? Almost and that is the after oxygen and silicon, it is the third most abundant element. That is the third most abundant element. Third most abundant element after the oxygen and silicon. After oxygen and silicon. After oxygen and silicon, it is the third most. In nature, oxygen in earth, oxygen is the most, its first position priority of oxygen is, it is the first metal that have very greater amount in the atmosphere in the earth, while after that silicon is the second most abundance in nature. After that aluminum is the third. Aluminum is the third metal. Aluminum is the third metal that have the in nature, that have the most abundant in nature, that are available in earth crust. In earth crust, the most important ore of aluminium is bauxite. Aluminium is bauxite. Bauxite, not bauxite. Bauxite, it is the most important ore of aluminium, while boron is, in this case, in this family, boron is very rare. Boron is fairly rare element, but it is also, it is well known because its occurrence is concentrated deposit of borax. It is present in the form of borax, but it is rare. In nature, it is rare. Not borax rare, but boron, it is in nature, it is rare. But it can be found in borax. Also it can be found in kernite. And tourmaline crystal. These are about boron, while gallium is twice abundant as boron. Gallium is most abundant in nature as compared to boron. It is twice of boron. Gallium is twice in nature as abundant as boron. Yeah, this is the fact. Also gallium is also present in Ga2 in it form. It present in mostly it present in Ga2 form in molecule. Ga2 molecule, it is present in Ga2 molecule, while boron, it will, while the other elements, that is indium and thallium, are much less common. Indium and thallium are much less common, in nature. All the three elements, that is gallium, indium and thallium, occur as sulfide and traces as zinc and lead sulfide ore. It also, these are that is gallium, indium and thallium these are also occur as sulfides and traces in zinc sorry to get correct position of camera, and get traces in zinc and sulfide ores. Yeah, these all are about the abundance and occurrence of the boron. I hope this point will be clear. Okay, let's come to the next point, that is atomic and ionic radius, next characteristic of boron family. I am cleaning the board. You can take screenshot or you can rewind the video. Okay, thank you. The next characteristic, that is fourth one characteristic. This next characteristic is that is the atomic and ionic radius. Let's explain this atomic and ionic radius. What is the atomic radius and ionic radius of boron family? Here is some abnormal behavior in the group related to the atomic radius, not the ionic radius. Okay, let's start. The atomic radius of boron, the atomic radius increases. The atomic radius increases from, that is the general, let's say, first of all I am writing boron, aluminium, gallium, indium and thallium. This is the atomic radius, while here is ionic radius. Yeah, remember that AR means atomic radius, while IR means ionic radius. So the atomic radius of boron is 85, that is in picometer, in both are in picometer, while the ionic radius will be in m plus 3 form. When there is the ion of m plus 3 means when each atom lose 3 electrons. So atomic radius of boron is 85, while aluminium has 143, while gallium has 135, indium has 167, while thallium has 170. While the ionic radius is 27 of boron, 3.5, aluminium, gallium has 62, while aluminium has 8, indium has 80.0, while thallium has 88.5. These are the ionic radius and atomic radius. So in atomic radius, in sequencer, the atomic radius increases from boron to aluminium. Atomic radius increases. AR means atomic radius. Atomic radius increases from boron to aluminium, After that, while ionic radius throughout increases, that is 27, 53, 62, 80, 88.5. However, gallium is an abnormal behavior. We will be discuss each of them with solid reason, with solid logic. While gallium has abnormal value of atomic radius, which is lower than aluminium. Means initially atomic radius increases from boron to aluminium, while the gallium has the abnormal behavior. It has less atomic radius as compared to aluminium. I hope my points will be noted. The sharp increase of atomic radius in aluminium in sequence, like in boron, aluminium, the sharp increase of aluminium in atomic radius of aluminium is 143. Why as compared to boron? Why is this? It is because in aluminium, I already told you in the electronic configuration points that in aluminium one extra shell will be added to the one extra inner shell will be added to the system. So here in aluminium, 3 is the outermost shell, that is also called, you can say that K shell is the first shell, while L shell is the second shell, that is the nucleus. K shell is the first shell, K is the first shell, while L is the second, while M is the third shell. So here in aluminium, here the outermost shell is the valence shell is M shell. So that's why in boron here is only 2 shell, K and L shell, while in aluminium here is 3 shell. So this means that the screening effect increases. One extra shell has been added to the system, to the nuclear. So that's why the nuclear charge or the radius, atomic radius become increased. So that's why this sharp increase from boron to aluminium it will occur. I hope my point will be clear. The new penultimate shell, that is L shell, will be added in aluminium. That's also called penultimate shell. Penultimate shell means the inner to the valence shell. Or you can say next to the outermost shell. A penultimate can be defined next to the outermost shell. Yeah, this is for aluminium, while this is for boron. This is the nucleus, this is the K shell, this is the L shell. this for boron here is only 2 shell, while in case of aluminum which has 3 shell, so this why the valence shell is that this is the valence shell, M shell is the valence shell, while in case of boron L shell is the valence shell. So here penultimate shell or inner shell in case of aluminum is 2, while in case of boron is 3. So in case of boron is 1. So that's why the nuclear charge on the nuclear force on the electron and the valence electron in case of boron will be greater because of less screening effect. The less number of shell will screen the nuclear charge, while in case of aluminum more the number of shell, one extra penultimate shell increases to the system to the. So that's why it will screen, it will it will cause shielding effect to the nuclear charge. So that's why the atomic size will be greater, which is 143 picometer as compared to the boron which have 85 picometer. I hope my point will be cleared. So why the next abnormal behavior, why the abnormal values of while the abnormal values are in atomic radius of gallium occur, why it will become decrease as compared to it need to according to sequence it will have greater the value of atomic radius as compared to aluminum, but it has lesser. Or then why, what is the reason behind this? Here gallium, indium and thallium, it follow after a row of 10 transition elements. Before this it is follow the 10 transition like this. This is the periodic table, so it become here is boron, here is aluminum, here is gallium, indium, thallium, so on here. So it become in aluminum, in case of boron and aluminum here is no d electron, while in case of gallium, indium and thallium here become it follow a row of 10 transition elements. So that is 10 transition elements in each row. So that's why there are 10 d electrons in the penultimate shell are added. 10 d electrons are added to the penultimate shell in each case. Penultimate shell which is next to the outermost shell, next to the valence shell. So that's why, and we know that the point should be remember that s shell produce s and p shell produce a more shielding effect, while d orbit or d shell it produce a less shielding effect, not effectively. The shielding effect will be not effectively. Less shielding produce less shielding effect. While in case of f orbital, f shell it produce very less very less shielding effect. It is because the d electron do not screen the nuclear charge in case of when there is d10 electron added to the penultimate shell, do not screen the nuclear charge in a z effective manner. Therefore the electron in the outermost shell of gallium experience more force of attraction toward nucleus than aluminum, causing thereby decrease in the atomic radius. Because here is the d10 electron enter into this system, and we know that the d shell produce very less shielding effects, very less shielding effects, not properly. So that's why the atomic radius will be decreased and shrinks, and the atom will be become shrinks of before it should need that the size become, let's suppose the size become like this, but it becomes shrinks due to the d shell which produce very less shielding effects. That's why it becomes shrinks and the size become reduced, which have 35 as compared to the normal that has that should need to increase more size than aluminum. So that's why but their size is less than the aluminum. The reason of this point is this that I told you, that I explained you. Due to this, thereby decrease in atomic radius. The atomic and ionic radius of group 13 elements are smaller than the corresponding elements of group first and second, that is also called alkali and alkaline earth metal. I hope my points will be cleared. Next point is the atomic and ionic radii of group 13 elements. Of group 13 elements are smaller than the corresponding elements of group first and second, that is also called group first and second. You can write it like this: group first and group second. The atomic radii or ionic radii of group third A, it will be less than this because what is the reason behind this? That is, let's suppose that is the lithium, beryllium, boron. That is boron. Lithium is the first. This is the group first, which is lithium, group second, which is beryllium, and group third, which is boron. Similarly, here in case of group A, which is in third period, which is sodium and magnesium in second group, and aluminium in third group. So let's suppose their size, atomic radius. Atomic radius of lithium is 152 picometer, while in case of beryllium, which has 112 picometer, while in case of boron, which has 85 picometer atomic size. In case of sodium, which has 186 atomic size, atomic radius, while the magnesium has 160 picometer atomic radius, while aluminum has 143 picometer atomic radius. So what is the reason why the atomic radius of the boron family or group 3A are less than the alkali metal and alkaline earth metal? That is also called, the group first is called alkali metal. These in the first groups, all the elements are metals, also called alkali metals, except of hydrogen, which is non-metal. While in second, all the elements are metals. No one can be non-metal or metallized. All the elements are metal. While in case of group third elements, all the atoms are metals, except boron. Boron show in between the metal and non-metal, so it will be called metallized. But mostly the properties of boron is similar to the non-metals. Except the boron, all the elements are, that is aluminium, that is the aluminium, gallium, germanium, aluminium, gallium, indium, and thallium. These all are the metals, properly metals. So what is the reason behind this? That why the atomic radius of the group third are less than the group second and first? This is due to the fact that the effective nuclear charge, that is the effective nuclear charge can be represented Z E double F. E double F means effective, Z means charge, charge of nucleus. So Z effective nuclear charge increases and electrons are pulled toward, resulting in a decrease. Why is it effective nuclear charge increases from left to right in the periodic table? It is increased because the number of proton increases. Number of proton increases while this while the orbit or shell, while the shell become constant, be, while the shell are constant in period. So that's why in constant shell number, when the number of proton increases, it means that z effective means nuclear charge, effective nuclear charge will be increased. So that's why the electron will be more close toward, it will be more attracted by the nucleus. So that's why the atomic size will become shrink and the atomic size reduce. So that's why the group third will have less atomic radius as compared to the group second and as compared to the group first term. I hope my points will be cleared. The next point in atomic radius and atomic size is, I am cleaning the board because of lack of space. Okay, let's take the correct position of the camera. Okay, here in isoelectronic species, electronic species, it means that in which electrons are same. Isoelectronic mean, iso means same, electronic mean same electrons. So in sodium, like in sodium, in magnesium, that is in sodium, that is magnesium, that is aluminium. Sodium which has 11 atomic number, magnesium which has 12 atomic number, aluminium which has 13 atomic number. Means in each cases the atomic number, that these are not isoelectronic species because the electrons are not same. So when sodium is plus charge, it means that it have 10 electrons, while when Mg has plus 2 charge, means with the last 2 electrons. So that's why it will have 10 electrons, while in aluminium it have plus 3 charge, mean when they lose 3 electron, it will have 10 electrons. So these species are called, isoelectronic because electrons are same. So in isoelectronic species, the atomic size or the not this is called, now this is not called ionic species. This will not this is called atomic radius. This will be called ionic radius, IR. That will be called ionic radius. So ionic radius of sodium is 102, while magnesium has 72 picometer, while aluminium has 53.5 picometer in case of isoelectronic species. So in case of isoelectronic species, why the size, why the ionic radius decreases? It become decreased because the Z effective charge to mass ratio, charge to Z effective to charge ratio increases, because here is more the charge on less electrons, more the effective charge, more the Z effective, more the effective charge, more the nuclear charge, nuclear force on the of attraction on the electron will have more. So that's why it will, on less electron, so that's why it will have reduce the size. In case of magnesium, in case of sodium, which have the less number of atoms, which have the less nuclear force on the electron, on the same electron, nuclear force on the same electron, less nuclear force on the same electron, while in case of aluminum more the nuclear force on the same electron. So that's why in case of aluminum the ionic radius will be reduced, while in case while sodium have greater ionic radius. These all are about the atomic and ionic radius. So now I am cleaning the board. You can take screenshot or you can rewind the video, and also please subscribe my channel. It make me feel happy that my students are supporting me. Please subscribe my channel and share it, this link, and share the video link with your friends, your classmates, so that your classmates also take advantage of the lecture. Okay, thank you. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal or Gmail that I put in description box. Okay, thank you. Let's proceed the topic to the next point, to the fifth point. I am cleaning the board. Next point is, the fifth point is density. What is the density of the boron family? Density of boron family, density of group third elements, it increases from boron to thallium. Let's show you. That is the aluminium, that is the boron, aluminium, gallium, indium, thallium. That is the 13th group, or group third of A. The elements and density. These are the elements and These are the density of boron is density in gram per ml. Gram per ml. Density of boron is 2.4, while aluminum has 2.7, while gallium has 5.9, while indium has 7.3, while thallium has 11.9. Mean the density is increases from the boron to the thallium. It also means that the density of group third elements increases from top to bottom in the periodic table. Density can be defined as the mass per unit volume is called density. Mass per unit volume is called density. The ratio of mass and volume is called density. So in periodic table from top to bottom, the atomic volume increases, but the atomic mass increases too much. So that's why the ratio of mass and volume will become more as compared to the boron and aluminum, which have very little mass. However, the boron and aluminum have comparatively low values as compared to the gallium, indium and thallium. This is due to their lower atomic masses as compared to gallium, indium and thallium. So that's why their density is lesser as compared to the gallium, indium and thallium. I hope the points will be cleared. And the next topic after this, almost this is 6 and 7 points are remaining. 6 and 7 different characteristics are remaining. We will be explained one by one, bit by bit in the next video. And I hope today lecture will be clear. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. Also you can get from there, that is +923447, my personal WhatsApp 82425458. This is my personal WhatsApp. You can also contact me here. Okay, thank you very much. Very best of luck, my dear student. Okay, thank you.